Hi, this is Martin Lindsay from the Studying Learning Centre at RMIT University. This is a short movie on factorising quadratics. The general form of a quadratic expression is given by ax squared plus bx plus c. Here, a, b and c are constants and x is the unknown. For instance, here's an expression, 2x squared minus 3x minus 4. A is plus 2, B is minus 3, and C is minus 4. Note carefully the sign for each of the numbers. Let's go back a step first and look at revision of expansion, in other words removing brackets. Here's an expression, x plus 2, x plus 3, and when you expand that, you multiply each term in the first bracket by the terms in the second bracket to get an answer of x squared plus 5x plus 6. We've done this in a previous movie. Now, factorisation is the reverse of expansion. In other words, x squared plus 5x plus 6 can be expressed as the product of two factors, x plus 2 and x plus 3. In other words, as you go from left to right in this equation, we're factorising. As we go from right to left, we're expanding. A few important things to notice about factorisation. First of all, multiplying the first terms in each bracket gives the x squared in the expression. In other words, x times x is x squared. Multiplying the last terms in each bracket gives the constant term plus 6 in the expression. In other words, plus 2 times plus 3 is plus 6. Finally, the coefficient of the x term, in other words, the middle term, is the sum of the last term in each bracket. In other words, here, plus 2 and plus 3 is plus 5. Now we'll be using these steps to work out some of these examples that follow. So, in general, for the expression ax squared plus bx plus c, where a is equal to 1, multiply two numbers to get c, we add the same two numbers to get b. In other words, we insert one number into each of the brackets. And secondly, the order is not important. In other words, the second bracket could be the first and vice versa. It doesn't matter which way around you place the brackets. So here's our first example, x squared plus 9x plus 14. So straight away we can place two brackets, as I've done, to the right of the equal signs. Using the rules, we need two numbers that when multiplied together gives us the last term, 14, and those same two numbers that when added gives us the coefficient of x, the middle term, which is 9. So we can look at 14 and 1, 7 and 2, and so on, until we get those two numbers that when multiplied gives us 14, but also added gives us 9. And those two numbers are 7 and 2. 7 times 2 is 14. 7 plus 2 is 9. Notice if I use 14 and 1, multiplying them is fine, but adding them will not give us 9. Let's look at another one, y squared minus 7y plus 12. Here we have a negative sign in the middle term, which makes it slightly more difficult. But we still use the same idea as in the previous example. In other words, two numbers that multiply gives us 12, the same two numbers that when added gives us minus 7. So we can look at 12 and 1, 6 and 2, 4 and 3. Notice when we look at those different combinations, those factors of 12, there's only one that will satisfy the two conditions, and that is minus 3 and minus 4. Notice minus 3 times minus 4 is plus 12. Minus 3 plus minus 4 is minus 7. So our answer is y minus 3, y minus 4. Here's another one. Notice the terms are separated by negative signs, p squared minus 5p minus 14. Again, using the rules, multiplying the 2, we must get minus 14. Adding the two numbers, we must get minus 5. Here it's not so difficult because we only have 14 and 1, that gives us 14, but 14 and 1, there's no way in which when adding those two numbers, whether they be negative or positive, will give us minus 5. So the solution to this is p minus 7 and p plus 2. Be extra careful with the negative signs here. Notice that minus 7 times plus 2 gives us minus 14, and minus 7 plus 2 is minus 5. And finally, here's another one, a squared plus 6a minus 7. We need two numbers that multiply to give minus 7 and two numbers that add to give plus 6. So we don't have much choice here. The only factors we have of 7 are 7 and 1. So they must be 7 and 1. But the difficult problem here is to work out where the negative signs go. And this usually comes just with trial and error. In other words, a plus 7, a minus 1. 7 times minus 1 is minus 7, plus 7 minus 1 is plus 6. If you tried minus 7 and plus 1, you would notice you would not get plus 6a. So try the different methods to make sure you're correct. Now try some problems for yourself. The answers to these questions are on the next slide. Thanks for watching this short movie.